Okay, what is the latest version of Java you have worked on?
Yeah, so I have used on Java 11.
Okay, can you please tell me the what are the features which has been introduced in Java 11?
Yeah, so Java 11 introduced various features like var keyword, I remember. So, like var keyword was introduced in Lambda expression. So, as a local variable, we can use it. And then in the string methods, several sorry, in the string class, several methods has been introduced now, like I think each blank is there, and lines, then strip, then strip leading, strip trailing, and repeat. So these are the methods which has been introduced. And then optional, in optional class, each empty method was introduced. And also the uh, now we don't have to run, I mean, in order to run the Java uh, file, we don't have to compile it first, so in a single go we can run it. So we don't have to say Java C and then run, so directly we can run it. And some older features and APIs were deprecated or removed, so that was also one thing. Then something related to garbage collector, also some improvement has been done. So yeah, so these are the things which I remember, which has been introduced in Java 11.
So you must have used Java 8 features as well in your projects, right?
Yeah, I have worked on it.
Okay, so um, when we come to the functional interfaces, right? So we have default methods over there. And earlier also we had abstract classes, right? And with the methods inside it. So more or less we see these default methods in Java 8 provide the similar kind of features what abstract methods have. So do you agree with this? And how do you think that it is different from the earlier one, earlier used abstract classes?
Um, yeah, so basically these two are, I think, two different things. Yeah, it is little bit similar, but we would not say it is same, because in case of abstract methods, so we will have the methods in the abstract classes, but we don't implement it. So whatever the class implement it, so abstract methods must be implemented by the classes that implement the interface. And default, in case of default methods, so it provide a default implementation already, so allowing implementing classes the option to override them or use the default behavior. So it's up to the implementing classes, so it's not mandatory to override it by the uh, implementing classes. So I think this is what is the major difference between these two.
Okay, how does the stream work in Java 8? So, can you explain the difference between intermediate and terminal operations with respect to stream?
So in Java, streams provide a way to perform complex data processing using a functional programming approach. So they are designed to work with collections of data in a declarative manner, allowing operations to be chained together in a pipeline. So it has some terminal and intermediate functions. So some of the intermediate operations are like filter is there, map is there, sorted, distinct. So these are the intermediate operations. And again, coming to the terminal operations, so we have collect and for each, reduce, count. So these are the terminal operations. So basically, intermediate operations are lazy. They return a new stream. They can chain together to form a pipeline. So they are lazy. They won't be executed until unless the uh, f- terminal operation is invoked. So the intermediate operations are lazy and terminal operations are eager. So terminal operations trigger the processing of the entire stream pipeline, and they produce the result or a side effect. For example, suppose we have the list of fruits, say apple, banana, or whatever list of items we have, and then we can say list dot stream, and then we apply the intermediate operation like dot filter. So we can filter, I mean, using the lambda expression, let's say s dot starts a, and then again we can also after that we can collect it. So dot collect, and then collectors dot to list. So here filter is the intermediate and collect is the terminal operation.
What are the changes which has been made with respect to date, time, and calendar in Java 8 compared to the previous versions?
Yeah, in Java 8, the old Java like .util .date and util .calendar classes are not modified, but were effectively replaced by a new date and time API introduced in Java .time package. A new package has been introduced. So there are many improvements which has been done in the newer version of uh, the time package. So the new date and time classes are immutable. So this makes them thread safe and easier to work with in concurrent applications. So also it has the new API. So it has better API design and it's more consistent. Methods have meaningful names and provided better functionality, and it has time zone support as well. So the zone id and zone date time classes provide comprehensive support for time zones and uh, like daylight saving time. The new API provides methods for adding and subtracting dates and time, so which makes it easier to perform calculations. So the improvements include better support for time zones, date, and the time arithmetic formatting and parsing, and comprehensive temporal adjusters. Yeah.
Okay, so can you tell me when to use sequential stream and when to use parallel stream?
Yeah, sequential stream processes data one element at a time in a single thread. So we should use sequential stream when order matters, like we should use sequential stream when the order of execution is important. Parallel stream we should use for large data sets, so and which in which order it does not matter. It is beneficial for large data sets where parallel processing can significantly reduce the time required to perform the operation. Then sequential stream, normally we have a small data sets, then we should use that. And simple, for simple operation also we should go for the sequential stream only. So it is ideal for simple non-complex operation that don't benefit significantly from parallel processing. Parallel stream when the operation of the stream are CPU intensive and can be parallelly effectively. So for CPU intensive operations we use it. So basically we should choose sequential stream for simplicity, predictability, and smaller data sets where parallel stream would not provide significant benefits. We should opt for parallel stream for large data sets, CPU intensive operations, and when performance can be significantly improved through concurrent processing. So always we should consider the nature of the task and the data involved to make the informed decision.
Okay, so you have worked on Lambda expression of Java 8, right? So, uh, can you tell me how do you handle checked and unchecked exceptions in Lambda expression?
Checked and unchecked exception. Okay. Uh, yeah, so basically in lambda expression, unchecked exceptions that can be thrown directly in lambda expression, unchecked exception. So we can handle them using a standard try catch block. So in try we can write let's say some whatever the method we want, and in cache we can directly handle for unchecked exception. But coming to the checked exception, it is not straightforward. So there are some workarounds we need to do for that. So um, for checked exception, the one strategy we can use of wrapping the checked exception in unchecked exception. So we can wrap checked exception in unchecked exception, and then we can throw it. So we cannot do it directly basically. And there is another way. We can also use custom functional interface. We can create a custom functional interface that allows checked exception. So that is the yeah, another way.
Okay, can you explain what is the difference between stream and parallel stream?
Yeah, stream and parallel stream are both used for processing sequences of elements, but they differ in their execution approach. So, stream processes elements sequentially in a single thread. So, each step in the pipeline is executed one after another. So, in parallel, stream processes elements in parallel using multiple threads. It divides the stream into multiple substreams that can be processed concurrently.
Okay, can you explain the difference between final, finally, and finalize in Java?
Okay, final, finally, and finalize. Mm, so, final is a keyword in Java used to define constants, prevent inheritance, and ensure immutability. So, final we can use it either as a variable or with the method or final class. So at these three places we can use it. So when we use it with final variable, so a variable declared as final cannot be assigned once it has been assigned a value. So normally for constants and all we use this. And final method in a final method declared as final cannot be overridden by subclass, and a class declared as final cannot be subclassed. So this is how the final used. And then finally is basically used like we used with try catch and finally. So basically this is a block. So finally is a block used in exception handling to execute a block of code regardless of whether an exception is thrown or not. So it does not matter we have catch or not, so finally always executes. So basically it is used to release the resource release the resource or perform cleanup actions such as like closing files or some database connections. Coming to finalize, so finalize I think is a method in the object class, so that is called by the garbage collector before an object is destroyed. So finalize can be overridden to perform cleanup operation before object is garbage collected, and such as releasing non-java resources.
Suppose any collections related requirement comes to you. Okay, so they have not asked you that what collections you have to use. So basically, what are the best practices for using the collections in Java? So how do you decide which one to use and when?
Yeah, for that we understand the requirements first. So we select the appropriate collection type based on our needs, like for ordering duplication or if it is any key value pair type. So I mean we can use list for ordered collections with duplicates. We can use set for unique elements, and we can use map for key value pairs. So anything related to key value pairs, we will go with map. Again, suppose we have to use list, then suppose the requirement is something related to the fast random access. So in that case, we use array list. Linked list we go for the frequent insertion and deletion. So then we go for linked list. Hash set and hash map for fast lookups, and tree set and tree map for sorted collections. So anything related to sorted or sorting, then we use this tree set or tree map. Again, while performing all this, we use generics for type safety. So always use generics to ensure type safety and to avoid class cast exception. Again, suppose if we have to ensure that the collections cannot be modified, if we have the requirement something like that, in that case we use unmodifiable collection. So like collections dot unmodifiable list, and then we can pass the list to that, so it won't be modified and it will become immutable. Also we should use concurrent collections for thread safety. So we can use concurrent hash map, copy on write array list, and one more is there, I think concurrent queue or something like that. So these we have to use, we should use for thread safety. So yeah, these are the various ways uh, we should uh, keep in mind while using the collections.
Do you know what is fork join pull?
Sorry, fork.
Fork join pull.
No, sorry, I'm not aware of it.
It is something related to executors. Do you know executors?
Yeah, it provides a high level mechanism for managing and controlling thread execution.
Okay. What are the primary annotations you have worked with in Spring Boot application?
Yeah, in my experience with Spring Boot, I have worked with a various wide range of annotations. So, in core Spring annotations, I have worked with a Spring Boot application, at the rate of Spring Boot application, and then at the rate of component, at the rate of service, at the rate of repository, controller, REST controller, uh, at the rate of configuration, at the rate of component scan. So basically at the startup of the Spring application, so there we use these annotations: add configuration, add enable auto configuration, add the component scan. And then there are various dependency injection annotations are there, like at the rate of auto wide, at the rate of qualifier, at the rate of value is there. Then for configuration also we have at the rate of configuration, at the rate of bean, at the rate of profile. Yeah, so and again if we are using aspect oriented programming, so at the rate of aspect I have used, and in that also we have before, after, and around. So yeah, these are the various annotations I have used. And coming to Spring MVC also, like whenever we make any API calls and all, right? So at that time also we use at the rate of request mapping, and then at the rate of path variable, at the rate of request parameter, request body, and then get mapping, post mapping, put mapping, delete mapping. So yeah, so all those annotations I worked with. Yeah.
Okay, how the request flows in a Spring Boot application. So let's say in UI user is performing any action and invoking web services or endpoints. So let's say user might be trying to update or delete something, right? So how this whole thing or whole flow works? Can you explain this in like how this works and what configuration and what the things we do for all that?
Yeah, so you mean uh, let's say we have any UI is there, and suppose any button or something is clicked over there, and after that, let's say we clicked on the delete, then how this delete reaches to Spring Boot application, the controller and service layer and repository, and deletes the from the database, right?
Yeah, this whole flow, can you explain in very brief?
Okay, so first of all, it's like user interacts with front end application, and it can be any web application, like let's say any um, maybe Angular, React, or whatever application it may be. So let's assume it clicks on a button to let's say update a resource or something. Then the front end application sends an HTTP request to the backend server. So this could be a put request for updating a resource, or delete request for deleting a resource. So uh, after that it reaches to dispatcher servlet. So so the request first hits the dispatcher servlet, so which is the front controller in Spring Web application. So the dispatcher servlet is responsible for dispatching request to appropriate handlers or controllers, you can say. So after that, the dispatcher servlet consults the handler mapping to find the appropriate controller class and method that can handle the request based on the URL and HTTP method. So whatever we have filed from the UI. Then after that, in the Spring Boot application, so we have I mean we would have written one controller class, so in which we will have a class, and on top of that we will have the annotations like at the rate of rest controller and um, at that request mapping, and we will have the various methods inside it. So let's say we have the employee controller is there, and suppose we want to update or delete employee. So in this class basically we will have the whole um, methods like delete employee, add employee, edit employee, update employee. So all those methods will be there. So CRUD operation will be there, and then suppose if it is a update employee is there, so on top of that we would have written at the rate of put mapping, and then we will have the ID. We will be putting ID over there, so that ID would be mapped with whatever from the UI we are passing. So it will take that ID, and further it will, so from this controller it will be calling to service layer. So so in the service there will be a class, so on top of that we will be marking as at the rate of service. So that will be the, we say that service layer, and there we will have the method. So suppose update employee method will be there, and in that further we will be calling the repository class, and the the service layer interacts with repository layer to perform CRUD operation. So the repository layer is typically an interface that extends JPA repository or another Spring Data repository interface. So it will be like uh, employee repository extends JPA repository. So after that, database interaction will happen. So if you want to update, there will be a save method will be there in repository layer, so that generates an update SQL statement to modifying the existing resource in the database. And if you want to delete it, so um, we will have delete by ID and method in the repository layer, so it will generate the delete SQL statement to remove the resource from the database. And then further the response, whatever after deletion we receive, that is further sent to the again back to the service layer, again to the controller, and further to the UI. So that is how this whole flow looks like and it works. Yeah.
Okay, so in Spring Boot project, can you explain how do you configure two or more than two different data sources?
Yeah, to configure two different data sources, let's say such as MySQL and another one is Oracle. In Spring Boot, we need to follow some steps. So first of all, the first step is like obviously adding the dependencies to pom.xml if it is a Maven, or build.gradle if it is Gradle. So we add Spring Boot starter data JPA. So we define properties in application.properties or YAML, whatever we are using. So we define separate properties for each data source, specifying the URL, username, password, and driver class name. Let's say for both MySQL and Oracle. Then we create configuration classes. So we create separate configuration classes for each data source. So these classes will be annotated with add configuration and will define beans for data sources, entity managers, and transaction managers. So we can use at the rate of primary annotation to specify the primary data source if necessary. This is not mandatory. Then we configure entity managers and transaction managers. So in the configuration classes, we configure the entity managers and transaction managers for each data source. So this involves like creation of local container entity manager, factory beans, and JPA transaction manager, specifying the package to scan for entity classes and repositories. And then we specify repository packages. So we use in at the rate of enable JPA repositories annotation in the configuration classes to specify the base packages for the repositories associated with each data source. So this allows Spring Boot to correctly identify and manage the repository for this two different databases. So yeah, so by following these steps, we can ensure that the Spring Boot application can manage the two different databases connection. Yeah.
Okay, suppose if you want to initialize the database with some initial values as soon as Spring Boot application starts. So, how can you achieve this? So, how can you make sure that all this data gets inserted to database as soon as Spring Boot application starts?
Yeah, this can be done using data.sql file in by placing it in the source main resources directory. So Spring Boot will execute this file to insert initial data into databases when the application starts. And optionally, we can also include a schema.sql file to define the databases schema. So like we can write insert a statement, insert into users, and let's say it has three fields. So that insert query we can write, and then using data.sql with JPN Hibernate also we can do that. So when we use JPN Hibernate, we can place data.sql file in the src main resources directory, and it will be executed automatically if the property this Spring Data Hibernate DLL auto is set to create or create drop. So yeah, so these ways we can achieve this. Um, and we can also actually, if we want, we can also use command line runner or application runner. So that is also one way. Yeah.
Okay, have you worked on profiles in Spring Boot?
Yeah, in Spring Boot, profiles provide a way to segregate parts of your application configuration and make it available only in certain environments. Like we can have multiple environments, right? We can have dev, we can have QA, production and all, right? So basically this feature is particularly useful for managing different configurations for development, testing and production environments. So profiles can be used to load specific configurations, beans or properties based on the active profiles. So for this we follow some steps. So we first of all we define profiles in application.properties or YAML, whatever we are using, and there is a property called spring.profiles.active. So we use this property to define it. So we can also define profile specific property files such as application dev dot properties, application test dot properties, like that. Okay, then uh, we can activate it by setting spring.profiles.active equal to dev. So whenever we do like this, so dev will be activated. Then based on this properties file, so we use at the rate of profile annotation in the class. So we can use at the rate of profile annotation on beans to make them conditional based on the active profile. So we use at the rate of configuration, and then at the rate of profile we can put dev under that on top of class, and then whatever the bean will be there, so on demand on demand this bean will be created. I mean, whenever dev will be activated, then only this bean will be created. So yeah, so this is the use of profiles, and normally it is so by using profiles in Spring Boot, we can manage different configurations and beans for various environments, making your application more flexible and easier to manage across the development, testing and production stages. Yeah.
Okay, so how do you handle inter-service communication between the microservices?
Yeah, so the inter-service communication can be handled mainly using two ways. So one is synchronous communication, one is asynchronous communication. So so synchronous communication typically happens using the REST API or gRCP. So this is straightforward but can lead to tight coupling and latency issue. And in case of asynchronous communication, so in this case we basically use brokers like RabbitMQ, Kafka, so all that. So this decouples the services and can improve reliability and scalability, but like it adds complexity in handling the eventual consistency.
Okay, so what is the role of a service registry in microservices?
A service registry is a database of microservice instances. So it keeps track of service available in a microservice architecture, so including their network locations. So services register themselves with the registry upon a startup and deregister when they shut down. So other services or clients query the registry to discover service instances. So this, for example, we have Eureka and Console. So like whenever we go for the microservice architecture, so typically whatever the uh, that small Spring Boot applications we have written, so all of them, I mean, whenever we start, so they get registered to the service registry, and then all this process happens.
Okay, so what is the concept of API gateway in microservices?
Yeah, an API gateway is a server that acts as an entry point for all client requests to microservices. So it basically provides a single point of contact for clients and handles requests by routing them to the appropriate microservices, right? So because as soon as we make the call, there might be multiple microservices running. Now, which microservices the hit has to go, so that is decided by the API gateway. The API gateway can also perform various cross-cutting concerns such as like authentication, logging, right, and this rate limiting and request response transformations. So all that. So like some of the API gateways are like Joule and then AWS API gateway. So these are the like commonly used API gateways.
Okay, so what is the circuit breaker pattern and why it is important in microservices?
Yeah, the circuit breaker pattern is used to detect and handle like any service failures, and suppose we want to handle it, so we go for using this. So it works by wrapping requests to external services and monitoring their success failure rates. So if the failure rates exceeds a threshold, the circuit break trips, preventing further calls to the failing services for a certain period. So like all this we can configure, and by doing this helps in avoiding cascading failures, improving system resilience. Libraries like Hystrix and I think Resilience 4J, so those we use to implement this pattern.
Okay, so how this history is implemented? Can you explain it step by step?
Yeah, so in order to use implement like Hystrix, so as soon as we create the Spring Boot application, so suppose if it is a Maven project, so we add the dependency. So let's say we are using uh, like Maven project, so we add the dependency first, and then after that, in the uh, main class of Spring Boot application, we write at the rate of enable circuit breaker, and then further we create a service class where we want to use Hystrix for fault tolerance. So we annotate the method with at the rate of Hystrix command and provide a fallback method. So it is something like we have a any my service class, and then uh, whatever the method is there, so like from where we are going to make the external call. So on top of that we can write at the rate of Hystrix command, and we mention there in a bracket fallback method, and the method name we mention over there. So whenever this failure will happen, uh, I mean that API call will fail, so it will call that fallback method instead of failing directly.
Okay, how do you ensure security in a microservices architecture?
Yeah, security in a microservices, like you can say, it involves multiple layers. So first of all, we have authentication and authorization. So for this we use auth2 or like JWT, so all that we use. So then we have API gateway, so that is a centralized enforcement of security policies and handling SSL termination. Then in service to service communication, so using MTLS, mutual TLS for encrypted and authenticated communication between services. Then security best practices, so by applying security best practices like input validation, avoiding sensitive data exposure, and regulatory updating dependencies. So yeah, these are the ways we ensure security in microservices architecture.
Okay, can you explain how you have implemented JWT in your application? Have you used it?
Yeah, I have used it. So basically, JWT stands for JSON Web Token. So it's a URL safe means of representing claims to be transferred between two parties. So the claim in JWT are encoded as a JSON object that is used as a payload of a JSON web signature, or as the plain text of a JSON web encryption structure, enabling the claim to be digitally signed or integrity protected with a message authentication code. So its structure is like it basically, JWT typically composes of three parts separated by dots. So like header, payload, and signature. So header contains metadata about the token, typically the type of token and the hashing algorithm used. And then payload contains the claims, which are statements about the and statement about an entity, typically the user, and additional data. And then we will have signature, so they are used for verifying that the sender of JWT is who it says it is, and to ensure that the message wasn't changed along the way. So in order to implement it, first of all, in suppose we have a Maven project, so we add the dependency of Spring Boot starter security first, and then we create a security configuration class to configure JWT authentication. So I mean, we create a configuration class, and there we annotate with at the rate of enable web security, and then we extend with web security configuration adapter, and that brings out one method which we override called configure. So that in the configure we give ant matcher, like whatever the URL will be there which should be allowed, I mean ant matchers, and then we give permit all with that URL, so that no authentication will be done for that. And then normally we use a JWT utility class, so that all the methods will be there, like creation of the uh, tokens, and get username from the token, and then validation of the token. So all these methods we can write in that utility class. So like while generation of the token, we mention there the expiration time, like it will be expired after how much time. So all that we can mention there. And as I stated earlier, like the signature will be what algorithm it will be using, so that signature and secret key will be putting over there, and that is how we can generate the token. Then we will have another method of validation of the token as well. And then we create a filter to intercept request and check the JWT. So again, uh, that filter basically, I mean, we create a component class, and that class extends maybe once per request filter that we can use. And again, this also overrides one method called do filter internal. So again, Then again here I mean the bearer authorization and all we do here. Then we create authentication endpoint. So in the REST controller class, so we prepare that, and then the endpoint we prepare in that class. So at the time of, maybe we will have a uh, post mapping method and of the login, and there whatever the request will come, it will go through that. So basically this controller handles login request and generates JWTs for authentication user. So yeah, so like this setup ensures that every request of our protected endpoints is authenticated using JWT. So this enhancing the security and enabling stateless scalable application. Yeah.